Hello everyone. In this video, I'm going to be creating a lesson, but I thought I'd just record how I did it, and then whilst I sort of play that recording back, just talk over some of the decisions on why I chose to write it this way or what we are sort of doing. And then the full explanation will be done in the course video. But effectively what we're doing is building a small box filling station, and I'm really just showing how to use CEM, the cause effect matrix, as some basic interlocks to go alongside a very basic sequence built in structured text or structured control language. So this is what we'll be building. Very, very basic. A flat pack box is placed at the G1 or gate 1, which has a proxy sensor on it, and then through some other means, a mechanical means, the box is unfolded. Proxy sensors, there's actually two here, prox 2 and 3, sense that the box has been opened, and then the box moves on to the weighing scale. We do a check where we tear the scale to make sure that we're not also including the box's weight, and then we fill the box, wait for the filling process to finish by the weight sensor being over 100 kilograms, and then we release the box further down the process. So a really easy one to get your head around, and quite a simple one to put together as well. So if I switch to the video, this was done from absolute beginning. So I start off by adding my interlocks. So I'm going to create an interlocks matrix, and you saw that I selected the CEM language. And the reason I've chosen CEM is because it's nice and visual. You could do it in ladder or any language really, but what I don't want to do is pepper my interlocks through my sequence. It's much nicer to have them outside of the sequence and then feed the actual end result or the effect to my sequence. I'm just putting everything that I need in right now, my proxy sensors and my weight scale. And then I'm setting some causes up. So I know that we need to check, is the weight scale less than, something that resembles just the box being there or nothing being on there. So less than 0.05 in this case. And then I also want to check, is it actually at 0 or above 0 to make sure that it's not unfunctional. So I'll put here weight scale 1 greater than 0. And then we finally will want a weight check to see have we hit our target. So I'll also have in here weight scale above whatever our target is. I'm just setting that one there to greater or equal to, because in a real scenario you might have exactly 0 there. It's unlikely with a real, but you could have exactly 0, in which case that condition needs to be satisfied as well. And then once I've added this in, I'll go ahead and create all of these as local inputs. I select them all, and then I have a shortcut on my mouse which brings up the define tag dialog. And from there, I can select all of them as local inputs and assign any incorrect data types. And I'm just fixing the actual causes, so they are checking if something is true. And then I will move on to effects. So these are going to be my actual interlock outputs, what I want to feed into my sequence. So G1 present, if I just bring up the image again, G1 present, so we're checking here now, is a box placed here, and then I'll have one for G2, which is going in there. And then this will be my fill start. I think I made a mistake here because I called this fill start here and then called the actual variable fill start, which Siemens won't like because it thinks they're both the same variable. And you can see already that it's put the little hashtag symbol or pound symbol to say that it's already a defined variable. And the reason it's still red, which is why I didn't notice, is because it's not compatible in that area. When I go to define the tags, it only brought up 2. And I went back then and changed this to G3 and G4. In hindsight, I could have just left them like cores 1, cores 2 here. I didn't actually need to assign them as anything, but I did. So change those to G3 and G4 and give them the output names that I want them to be. And then do the same sequence again of defining all of these as local outputs. And then I'll move on to doing the actual logic. So if anyone's ever used CEM before, it's nice and easy. You're literally drawing lines and just defining whether or not things are in groups. So that first one there, if prox1 is true, then G1 present is true. Whereas this one, prox2 and prox3 need to be true in order for G2 to be present. And this one, again, I'm putting in a group of 2. I need to be less than 0.05 and greater than 0 in order to start the fill. And this one here is just if you're over the target weight, then your fill is complete. I've just missed the assignments on G3 and 4, so just putting those in. And then it's a good idea to do a compile. I always do a compile once I think I'm complete with an object, because that gives me a little bit of confidence that I know I don't need to come back in here. It's all about registering the interface and assigning things to the interface from that point onwards. So that all compiled okay. And now what I'll do is drop this into my main OB1. Obviously, this is just for an example or for a lesson. So I'm going to make things a bit easier for myself by not actually doing all of the scaling of instruments like the weights and conditioning of the proxies. I'm just going to go ahead and create a sensor data block, and it will be this that lets me manipulate my sequence for the lesson. So this is something that I like to do when I am developing full-scale projects as well, splitting the window when I'm putting data sets together so I can see interfaces and marry names up and things like that, just to make it easy and make the flow of reading the code later much easier to tolerate. So we have sensor data, which will all come in on the left of my interlocks, and then I will create a new data block for my interlocks. So I'm not mixing what would be raw data, or it might be conditioned data, but sensor data, I'm not mixing that through with my interlocks. So I'll go ahead and create all of the G1, G2, fill start, and fill complete interlocks. And then it's a good idea to actually give this a little bit of context, a bit more using comments to tell me what this actually does to my sequence. So the first one, G1 present, is box present at G1, and then box open at G2, and then the weight check has been okay, so fill start, and then the weight fill has completed, so fill complete. And then from that split window, I can just drag them directly to my interface for my interlock matrix, which is something that's really, really useful. It is quicker than sitting there and typing them in. And then I need to populate my sensor data. So I do the same thing, click on sensor data, but this time take it from the details view. And that's just me being lazy, and that's closer, less dragging. And once this interface is complete, I can then move on to the sequence. So these interlocks give me everything that I need to tell my sequence to advance and for my sequence to actually do checks against, without having all the logic that's required to actually check, is the box at gate 1? Is the box open? I just need to have the supervisory sequence over the top now that actually manages the output, like tearing the scale and releasing the box at the end. So it is a very, very basic example, but the principles around it are the same no matter the size of the sequence that you're doing. I've created a new function block in SCL, or structured text. And from here, I'll just get started. The way I like to write in structured text is to write, and it will come up with all the squiggly lines saying that there's errors, that variables aren't assigned and things like that. And then I'll create those variables after, or once I've finished completing that section. So you can see here that case sequence of, or sequence doesn't exist yet, or SEQ doesn't exist yet. So I always create an idle case first. And in the idle case, I will then go ahead and put what my first idle check is. So we're waiting for G1 to be present. This sequence starts when a box is present at G1. So that's my first step complete. If G1 is present, then move on to the next step. So I'll go ahead now and create my sequence index or integer that's being looked at as part of the case. And then I will create my input for my G1 presence. And I'll also create a next step because I don't like writing directly to the sequence. If I have a next step there, then should a sequence be really complex, you can put a step system in, or a system that pauses the sequence and doesn't let it advance past certain steps and things like that, which really helps with commissioning and testing rather than just letting the sequence fly through. So I've now gone and created my input interface with all of the interlocks that I'm expecting to come into this sequence. And now it really is just about writing the sequence and defining the outputs. So I know that I will need a release output, which tells the system to let the box out. So if I come back to this here, that's this section here, box release. And then I know that I need to set it to false because it needs to be false at the beginning of the sequence. I don't want that output conveyor to be running when the sequence doesn't need it to. So the next step now is to wait for a box open. So the actual sequence isn't controlling the opening of that box, but we do have two proximity sensors that are part of our interlock system to make sure that box is open. So if G2 present, which is our interlock to say that a box is open, then move to the next step. And that's all that needs to happen in this particular part of the sequence. And now this is probably our most complex step, which is to check the scale weight. So we know we're moving a box on, so we should see a small amount of weight, but we want to tear that so it always equals 0 once the box is present. And to do that, I'm going to use a timer. Now, timers can't exist inside the sequence because you can get yourself in a mess where the next time the sequence comes round, the timer's already complete because it's no longer scanned once that step is no longer active. So I always put my timers outside of my case statement, which is my state machine or sequence, and then look at the current sequence step. So sequence equals 2, and then I have a 2-second timer, and I write it to a defined variable or a static variable. So what this will do is when we come into step 2, it will fire this timer, and then I'll look at this timer to make sure it's complete. So remember, I want to tear the scale. So I need to make sure that the timer is not complete when we come into this step for the duration that the timer is timing. So not complete, then set the tear scale to true. I think I lost my train of thought here when I was writing this, putting tear scale equals tear. But I then need to define tear scale as an output so the sequence can actually fire the event. Set that to a Boolean. And now, whilst this timer is timing, the scale will be teared back to 0. So now what I need to do is, once we're happy, so fill start from our interlocks, and the timer has completed, then we can move on to the next step. Oh, I also set the tear scale back to false because it's an output from the sequence. We don't want that to be true whilst the filling event is actually happening. So now we're waiting for the completion of the fill, which again is a very straightforward step of if the fill is complete, then we are done and we can release the box to the rest of the process. At this point, I'm pretty confident that my sequence is complete. I've got the steps that I need. So what I'm doing now is just in my mind running through the steps and making sure that things will go where I think they should go. So I'm checking here the timer. I set the timer up correctly. It's got its return to move on. And then I realized that we're sending everything to next step, but I don't actually set the step back to the sequence anywhere. So here, sequence equals next step, and that's the sequence complete. So a quick save of the project, which I think is the first time I've saved at this point, which is unlike me. I like to save very often. And then I move the box fill sequence into main OB1. And again, it's now time to marry up the interfaces. So just some quick copy and paste. So this is the link between our interlocks and our fill sequence. And then I need to define some outputs. So for this particular example, this output, it doesn't matter. There's no real IO or anything like that for the lesson, but I will give them some defined names using the rename tag. The release box, this would go off and release the box. And then tear scale, which would tear the scale. And now it's time to download. So I have a virtual PLC running in a VM, and it should be that I can click download and just download to that without any issues. I have a PLC that is just set up for lessons and things like that. So every CPU that I sort of start with is already configured to download to that one. So it should be a straightforward process, but TIA Portal, being TIA Portal, likes to make things difficult sometimes. So, so it makes me redefine all of my download of configurations when I've been downloading to this PLC multiple times through the week without it doing this, but because I'm recording a video, it likes to make this stuff happen. So trust the connection. And then TIA Portal did something I wasn't expecting, which was to tell me I can't download CPU. And it was nothing wrong with the actual project. What it was that the new Scratch project that I have open was not defined to download to a virtual PLC. So you'll see this come up now. So main OB cannot be simulated. And that's because if you come up to the project where I'm going now and go to the properties of the project and then protection. In protection, there's a checkbox that says support simulation and enable usage in virtual PLCs. I really don't understand why that's not ticked by default, or a warning couldn't be made when you go to download at the beginning, but it's all to do with weakening the know-how protection somehow. But yeah, that can catch you out if you're trying to download to virtual PLCs. So now I'm all downloaded. It's time to go online and check that the sequence actually works. Nothing works first time is always my motto, but this is very, very basic and it should work first time. And if it doesn't, it might be operator error. But I'm just setting up my screens so I can see everything that I need to see at the same time. And we're going to drive things from sensor data. So I go online to have a look and monitor the block, and then come down to my box fill sequence. I should have really put a sequence output so we could see what was happening, but this should put us in sequence step 1 because G1 is present, and then prox 2, And I realized that I need to set a target weight, otherwise when I do prox 3, it will just fall straight through the sequence. So this should now put us in the state where we are tearing. So if we look at the tear scale output, that's just gone true, and then back to false. And then if I set a value of 105, which is above our target weight, that should restart the system and release our box. So we won't see the release box because it'll just be one scan, a pulse that releases the box, because the sequence will restart again. But let's have a look at the actual SCL, and we'll step through it that way. So again, just having a look, and then I will set up my screen because monitoring SCL is not the best. I would much prefer Siemens did an inline monitoring of SCL rather than this sort of table to the side. But I noticed that we're also in sequence step 3 at the moment. So the sequence was just falling through because the proximities were all set to true. We are already above our weight target. So I just need to go and manually change that out of the step 3 by changing the current weights to above the target weights. So all the proxy sensors are off now. Set that back to 0. And we should be in sequence step 0 now, which we are. So if I set proxy sensor 1, we should fall to step 1, which we do. And then if I set proxy 2 and 3, we should fall into our tear, or step 2, which is waiting for tear, which we are. We're tearing the scale now. And now we've dropped into sequence step 3, where we are waiting for the fill to complete. And if I set the weight to 105, we should go back to sequence step 0 because sensor proxy 1 is set to false, so it shouldn't fall through now. Which we are. We're back in 0 and it's not progressing anymore. So that completes my sequence. So just going back to this, what we've done is a 2-block system, one managing the interlocks and one managing this sequence here. And yes, there are external factors that would have to be considered, and this isn't a perfect real-life example, but I just wanted to show the making of these lessons and what sort of thought process goes into putting these together.